You are listening to Pankaj Rai. In this series of videos on IUPAC nomenclature of carbon compound, this is the second part, and in this video we will be dealing with alkenes. So let us begin. Let us begin with a carbon atom. A carbon atom having 4 electrons in its outermost shell. Let's say there is one more carbon atom having 4 electrons in its outermost shell as well. Let's say that these two carbon atoms are sharing 1 electron each to form a covalent bond. So now both the carbon atoms are having 5 electrons. This carbon atom having 4 electrons of its own plus 1 which is shared by this one, and vice versa. Let's say that they also share 1 electron more and they form a covalent bond again. So now both the carbon atoms are having 6 electrons. If you look at the first carbon atom, it is having 4 electrons of its own, 1, 2, 3, 4, plus 2 extra which is shared by the second one, this one and this one. And similarly this one is as well having 6 electrons in its outermost shell. So they both need 2 electrons more to complete their octet. Let's say there comes hydrogen in the picture with 1 electron. Now this hydrogen will share its 1 electron with this carbon, and this carbon will share its 1 electron with this hydrogen, and they will be forming a covalent bond as well. Now this hydrogen has achieved its duplet, so it is stable. This carbon is having 7 electrons now. Let's say there is one more hydrogen having one more electron, and there is a bond formation here as well. Now as you can see that this carbon atom is completely stable with 8 electrons. Similarly, this carbon atom can also achieve its stability with 2 hydrogen atoms. So now the molecule or the compound itself is completely stable. This molecule would be written as carbon double bond with the another carbon, and single bond with a hydrogen, single bond with a hydrogen, single bond with a hydrogen, and single bond with a hydrogen. It will be written as CH2 double bond CH2, and this is our first alkene, which is ethene. I said the first alkene because methane could not exist. Let us move ahead. Let's say there is a chain of 3 carbon atoms, and let's say that 2 of them are forming a double bond. So there are two cases, either this one or this one. So I'll write both of them. So let's say a double bond is being formed here, or a double bond is being formed here. Now this carbon atom has 2 bond forms already, so it will be forming 2 more bonds with 2 hydrogen atoms. Let's say a hydrogen and a hydrogen. This one has 3 bonds, 1, 2, 3, so it will be forming only one more bond. This carbon atom has formed only one bond, so it can form 3 more bonds with 3 hydrogens. So this will be called as, this will be written as CH2 double bond CH single bond CH3. This is called as propene. Let us concentrate on this one. This carbon has formed only one bond, so it can form 3 more bonds with 3 hydrogens. This carbon atom has already formed 3 bonds, 1, 2, 3, so it can form only one bond with hydrogen. This carbon atom has formed 2 bonds, so it can form 2 more bonds with the hydrogen atoms. So the compound would be written as CH3 single bond CH double bond CH2. This is also called as propene. They are exactly same. They are just mirror images of each other, left to right and right to left. Let us move ahead by learning how to number the carbon atoms in a long chain. The rule says the numbering should start from where the double bond is nearest. In this case, there are 3 carbon atoms. It can be numbered as 1, 2, 3, or it can also be numbered as 1, 2, 3. Now look at this numbering 1, 2, 3. In this, the double bond is getting the first number. The double bond is between 1 and 2. So we say that double bond starts from the first carbon. Whereas if we do numbering in this way, 1, 2, 3, here the double bond is between carbon number 2 and carbon number 3. So we will say that double bond starts with carbon number 2, which shouldn't be the case. As I said, the rule is the numbering should starts from where the double bond gets the lowest number or appears first. So this numbering would be wrong. So there is only one way to number this. This is 1, 2, 3. Now here the double bond starts from 1. So this can also be written as prop dash 1, stating the position of double bond, dash ene. So it is also called as prop 1 ene or propene. Now let us concentrate on this one. Here there are two ways of numbering, 1, 2, 3 or 1, 2, 3. As you can guess, in this the double bond is occurring at second position, and in this series the double bond is occurring at first position. So this is the correct series, whereas this is the wrong numbering. Now here, as you can see, that double bond is starting from the first carbon. So it can also be written as prop 1 ene, one stating the position of the double bond. As I already told you, both the molecules or both the compounds are exactly same. They are just mirror images of each other from left to right and right to left. They both are called as propene, or they can also be called as prop 1 ene. Now let us move ahead by looking at 4 carbon atoms. Okay, now let us see a chain of 4 carbon atoms, 1, 2, 3 and 4. Now the position of double bond has 3 possibilities, first, second and third. So let me make 3 chains of 4 carbon atoms, the second one and this, the third one. There are 3 possibilities. Double bond could be here, or double bond could be here, or double bond could be here. Now this carbon has already formed 2 bonds, so it can form 2 more bonds with hydrogen. This carbon atom has formed 3 bonds, 1, 2, 3, so it can form only 1 bond with the hydrogen. This carbon atom has formed 2 bonds, so it can form 2 more bonds with hydrogen. This carbon atom has formed only 1 bond, so it can form 3 more bonds with hydrogens. Similarly, there will be 3 bonds for this carbon. There will be 1 hydrogen for this carbon. There will be 1 hydrogen for this carbon, and there will be 3 hydrogens for this carbon. Similarly, this has already formed 1 bond, so it can form 3 more bonds with the hydrogens. This has already formed 2 bonds, so it can form 2 bonds with the hydrogen. It has formed 3 bonds, 1, 2, 3, so it can form only 1 bond with the hydrogen. This has already formed 2 bonds, so it can form 2 more bonds with the hydrogen. This can be written as CH double bond, this is CH2 double bond, CH single bond, CH2 single bond, CH3. This would be written as CH3 single bond, CH double bond, CH single bond, CH3. This can be written as CH3 single bond, CH single bond, this is CH2 single bond, CH double bond, CH2. As I have already told you, the rule of numbering the carbon atoms, the numbering should begin from where the double bond is closest. So here the numbering would be like, it would be 1, 2, 3, 4. Here the numbering could be 1, 2, 3, 4 or 1, 2, 3, 4. In both the cases it is same because double bond is in the middle. Let's say this is 1, 2, 3, 4. This one, the numbering cannot begin from here. It should begin from here because this is the nearest carbon having the double bond. So it will be 1, 2, 3, 4. Now they all are butene, but the position of double bond differs in them. Let us concentrate on this one. Here the double bond is between first and the second carbon. So it begins from the first carbon, so it will be named as but 1-ene. This one, the double bond starts from the second carbon, so it will be named as but 2-ene. In this one, as you can see, the double bond starts from the first carbon, so it will be named as but, my mistake, it will be named as but 1-ene. As you can see, the first one and the third one, they are exactly same because they are the mirror images of each other from left to right and right to left. Both will be called as but 1-ene because the position of the double bond begins from the first carbon. But this is a different compound. It is but 2-ene because the position of double bond starts from the second carbon atom. Either we name it from this way, this side, or this side. So in this way, the naming of alkenes has to be done. Now, as we have seen that the general formula for alkane was CnH2n plus 2. That is, for every carbon atom, there were double hydrogen atoms plus extra 2. Now, as we can see here, there is one double bond. If this double bond wouldn't have been there, then there would have been one hydrogen extra here and one hydrogen extra here. That is, this alkene is having two hydrogen less from the corresponding alkane. Look at this. If this double bond wouldn't have been there, then there would have been one hydrogen here and one hydrogen here. That is, this alkene is having two hydrogen less from the alkane. Look at this. If this double bond wouldn't have been there, there would have been only a single bond. Then there would have been one hydrogen extra here and one hydrogen extra here. That is, again, this alkene is having two hydrogen less than the alkane. So simply the general formula for alkene is CnH2n plus 2, that is alkane. So those two hydrogens are not there. The corresponding alkene have two hydrogen less. So this is the final formula for alkene, which is CnH2n. Thank you very much.